This video is for the exponential parent functions and graphing exponential function notes. So our parent function, when we're talking about exponential functions, is f of x equals b to the x. Okay, so your exponent is your variable. So if b is greater than 1, the function is an exponential growth and is increasing. If b is less than 1, the function is exponential decay and is decreasing. And then we've got asymptotes when we're talking about exponential functions. So an asymptote is a line which the graph gets close to but never crosses. All right, so if we have the function 2 to the x, and we need to graph this. We need to classify it as growth or decay, graph it, and identify its key characteristics. So what we can do is we can create a table for this so we can have some points. And so you can graph 2 to the x, and you can pull up the table. And you can create yourself a little table here, x and y. So when x is negative 2, y is 25 hundredths. When x is negative 1, y is 5 tenths. X is 0, y is 1. X is 1, y is 2. X is 2, y is 4. And so now you have some points that you can graph. So if we graph this, I'm just going to start with 0, 1, and then 1, 2, and then 2, 4. And so this graph is going to skim along the x-axis here. It's never going to cross that x-axis, and then it's going to go up from there. So the x-axis here, I know it's kind of hard to see, that's your asymptote for this equation. So the domain, the value of x's, is all real numbers. You can use any value of x. The range, y has just got to be greater than 0, so you're never going to have any negative y's here. The end behavior, so as x approaches infinity, f of x, which is the y value, is going to approach infinity. And then as x approaches negative infinity, f of x, the y value, is going to approach 0. The y-intercept, where this crosses, is at 0, 1. And that asymptote is the x-axis, and so as an equation, we write that as y equals 0. So that is the equation for the x-intercept, is y equals 0. Okay, so let's do this one, 3 to the x. So we can do, let me put this here for a second. So if you need a pause to write any of that down, you can. All right, so 3 to the x, we could do the same thing. We can create a table. So I can go in here and create me a table, and I'm just going to change this to a 3 and pull up the table. So x and y, we've got negative 2, negative 1, 0, 1, and 2. So we've got 1/10 repeating, 3/10 repeating, 1, 3, and 9. So if I graph this again, I'm going to start at 0, 1, and then 1, 3, and then 3, 9, or 2, 9, sorry, it's going to be way up here at the top. So it's going to look very similar to the other one. It just gets steeper quicker. So again, we have this same asymptote here on the x-axis. And so our domain again is all real numbers. Our range, y has got to be greater than 0. The end behavior, as x approaches infinity, f of x approaches infinity. And then as x approaches negative infinity, f of x is going to approach 1. The y-intercept is 0, 1 again. And the asymptote is y equals 0. So these are both growth. So I'm just going to write growth in between them here. These are both exponential growth. All right, on your second page, we've got some different ones here. So we've got 1/2 x. So again, we're going to do the exact same thing. Pull this up. And try that again. Let's do 1/2 x. Oh, maybe. I got an extra equal sign in there. There we go. And pull the table. So for this one, go up a little bit more here. X and y, -2, -1, 0, 1, 2, 4, 2, 1, 5/10, 25/100. So if I graph this one, so I've got -2, +4, 1, 2, 3, 4, -1, +2, 0, 1, and then that's when we start getting close to 0. So we're hitting the asymptote again. So our asymptote is still the x-axis. And so our domain here is still all real numbers. We can use any value of x. The range is still y is greater than 0. The end behavior here does switch. So as x approaches infinity, so we're going this way, y, or f of x, is going to approach 0. And as x approaches negative infinity, f of x is going to approach infinity. The y-intercept is 0, 1, same point, and the asymptote is still y equals 0. Okay, so that one is a decay. So both of these here are decay. So we've got another one here, 2/3. So again, the value, the b value here, if it's less than 1, we're talking about decay. All right. So go and change this to 2/3. Pull the table up. All right, so if we make a table for this one, x and y, -2, -1, 0, 1, 2. So we've got 2.25, 1.5, 1, 6/10 repeating, 4/10 repeating. So if we graph this one, -2 and 2.5, I'm actually going to see, let's see if we can find a better point. Nope, they all look pretty gross. So -2, 2.5 is going to be somewhere in there. -1, 1.5. And so sometimes you just kind of have to do your best. Put points in there as they look okay. And so this one is not quite as steep. The asymptote is still the x-axis. And so my domain, again, is all real numbers. My range, y, has got to be greater than 0. The end behavior, as x approaches infinity, y is going to approach 0. As x approaches negative infinity, f of x, or y, is going to approach infinity. The y-intercept is still 0, 1, and the asymptote is still y equals 0. So both of these two, these are both decay, exponential decay functions. So one thing to watch out for or when they're written this way, 5 over 2. Your brain likes to get in the habit of going, oh, it's a fraction, it's decay. But if you graph this one, and we're not going to put this one on the page, I just want you to see what it looks like. If you want to put it on the page, you're more than welcome to. But 5 over 2, you can see that it has this growth. It's getting bigger. It's going the opposite direction. Where these are getting smaller, this one is getting larger. So always check your fractions. Again, you can do 5 over 2 and look at it as a decimal. The decimal is bigger than 1. It's going to be a growth function.